So I want to look at those three topics today: the radian, where it comes from, the definition of the radian, and how we can convert from radians to degrees, which is the more normal unit for angle. The idea of angular motion in a circle, angular velocity, and then how that's related to linear velocity. And finally, finishing off with looking at this rotation and plotting out these trigonometric ratios that can be found from considering a rotating vector. So that's the idea of today. So what I'll do is I'll split the video up into 3 sections, and I'll do one on each of those sections. So let's have a look at the radian first. So if we consider a circle, so if you want to sort of draw a freehand sketch of a circle, and then we consider x and y directions associated with that. So it's got an x and a y. So that if we consider a point rotating, and we generally consider anti-clockwise rotation as being a positive rotation, then we could talk about its position in terms of where is it on the x-axis and where is it on the y-axis. So we can give it a coordinate, or we can talk just about how far is it going up the y-axis or how far is it along the x-axis. The radian measure. If we consider an angle, so if we take this distance here to be r, the radius of rotation, and then we consider it moving around so that it moves to a new position here. So it's going around in an anti-clockwise direction. It's moved from here to here, and it's moved through an angle theta. So this angle theta, from there to there. We want a unit of measure that gives us an idea of how far it's actually moved around the outside of this circle, and that's called an arc length. From there to there, this distance is called the arc length. So we've got an arc length here, and we use the letter S to represent arc length. So this distance from here to here is the arc length. This measurement of angle then, that's going to give us an idea of how far we've moved around the circle from a point to another point. We could do with that in terms of the radius r. So what we do is define that in terms of r. In other words, if we say if this distance from here to here is exactly equal to the radius r, then we say that's 1 radian. So if the arc length is equal to the radius, we've gone around a distance of 1 radian. And if you think about it, it doesn't actually matter how big the circle is. So if it was out here and we went round to there, actually the angle that we've gone through would be exactly the same. So if we go around the distance which is the equivalent to the radius of the circle, we always go through the same angle. So to repeat, if the arc length equals the radius, the angle is 1 radian. Now if we think about the whole circle, we know the circumference of a circle, it's 2 pi times the radius. 2 pi r is the circumference of the circle right the way around. Right the way around this circle. I won't go right the way around because it does weird things if I do that. So if I go right the way around the circle, I've gone through 2 pi times the radius. So if we've defined the radian as the distance travelled if we're going by 1 through 1 radius, if you like, arc length, then all I've got to do is times that by 2 pi, and I've got the circumference. So in other words, there are 2 pi radians in one turn. Therefore, there are 2 pi radians in one turn. And we already know that one complete turn is 360 degrees, so that gives us a conversion factor. 2 pi radians, and RAD for short, equals 360 degrees, and that allows us to convert from radians to degrees and back again. So if you're going to remember how to convert from radians to degrees and back, the key thing to remember is what a complete turn is in radians, 2 pi. And then we just say, okay, that must be equivalent to 360. So then we can work out the conversion factors. There are a few key angles that are worth remembering. For example, as Tommy's already mentioned, pi radians is 180 degrees. Dividing again, we've got pi over 2 radians must be 90 degrees. And pi over 4 radians is 45 degrees. And so on. We could write down a few other key angles if we wanted to. What 60 degrees is, what 270 degrees was, etc. We could easily work out a few of them just by thinking of it in terms of pi. What would 120 degrees be, for example? Yeah. No. How many lots of 120 are there in 360 degrees? So it must be pi over 3. A third of pi, in other words. Sorry, a third of 2 pi. What am I saying? A third of 2 pi, because 2 pi is a complete turn. So it's 2/3. Is that right? Yeah, that's right. Because if I times that by 3, I've got 360 degrees, which is 3/6 or 2 pi. Okay. So we can work out angles. However, if I want to know what any angle is, like 12 degrees or 13 degrees or 150 degrees, I could do with knowing what 1 degree is. So I need a couple of extra things that I can work out. If, and this is the key one to sort of remember, if 180 degrees is pi radians, what's 1 degree? Right. Yeah. So 1 degree equals pi over 180. And that's important because we can then use that to convert any angle. So that's a good one to use. The other way is if I want to convert radians to degrees. So going back to our ratio, here again, if pi radians is 180 degrees, what's 1 radian? Over pi, yeah. Yep. So, or we've got 1 radian is 180 over pi. The other way around, in other words. No, to convert from one to the other, it's the inverse. Yes, that's right. It's not uncommon to do this conversion because when we're measuring angles to do with rotation, back to here again, we'll be doing work, and you'll be doing work, I'm sure, in other units to do with rotating vectors, machine parts, or even generators that generate AC electricity, rotations involved. So we talk about angles in radians. So you're going to be converting degrees to radians and back again. This is how you do it. That's all you really need to remember, that 2 pi radians is 360 degrees, because then you can say, okay, pi is 180, pi over 2 is 90. These are common ones people remember. Pi over 4 is 45, and so on. And once we've got that pi is 180, we can easily work out, therefore, 1 degree must be pi over 180, and 1 radian must be 180 over pi. So we can then convert. We can say, for example, 40 degrees, what would that be in radians on your calculator? And 3.6 radians, what would that be in degrees? So if you've done those on the calculator, hopefully that's the calculation you did, and these are the solutions you should get. Okay, so know how to convert radians to degrees and degrees back to radians again, and the conversion factor that you need to remember is this here. And from there you can work the rest out. Okay.